Hey guys, Mr. Yates here. Today we're going to be taking a look at solving problems using data. So behind me there is a bar graph, and then along the side here we have a few questions that we're going to answer, but we're going to get to those later. Whenever we have a bar graph or any data, the first thing that we want to do before we even look at the questions is make sure that we understand the data and we know what's going on in the graph. So let's look at what's going on behind me. This graph is entitled Ways to Get to School. Okay. Along the bottom, I can see the different forms of transportation. That's what the x-axis is labeled here, so I know that these are the different ways to get to school. So there are people that take a car, a bus, walk, and bike. Okay, it looks like, before I even look at the data, it looks like the most people ride the bus, and the least common thing would be people who are biking to school. Let's take a look at what this axis over here is telling me, my y-axis. This says the number of students, and it's counting 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. That's counting by fours. All right, cool. So now I want to kind of tie those things together. I know what's going on here because I read everything, but I still just see bars. And I don't know about you, but for me, I'd rather see numbers. Numbers are easier for me to work with, especially when we get to our questions, because those are going to ask us some things about numbers. So what I'm going to do is I'm going to draw right on here. If you're looking at a computer screen, you could maybe use your finger to go across, or you could use something that's flat and straight so you could see right across, or maybe it's going to have lines on there for you, which are really going to help. So let me draw in lines so that I can figure out exactly how many people come to school in the car, how many people take the bus, how many people walk, and how many people bike. So I'm going to take these lines over here, and I'm just going to continue them right on across. I'm going to make them a checkered line so they're easier to see. Awesome. And I'm going to stop there because I don't have anything higher, so I don't need to keep making those lines. All right. So now let's make this easier on ourselves. Let's assign these bars numbers. So the first one is how many people come to school in a car. I can see that that bar lines up perfectly with 16 students. So right on the top of that bar, I'm going to write 16. Now I know that in this data set, however many people they asked, 16 of those students came to school in a car. Let's look at how many students came in a bus. That bar, again, lines up perfectly with one of our dashed lines. It lines up with 24. So I know that 24 students came to school on a bus. All right, to make it a little trickier now, let's look at how many students walk to school. Now this bar right here, I can see, does not line up with this line or this line. It falls right in between those two. So what do? Well, let's look at the two lines that it falls between. That's falling between the, I'm going to trace it back, 8 and the 12. So I have to think to myself, what number is perfectly in between 8 and 12? That must be what this bar is representing. Oh wait, it's 10. 10 is right between 8 and 12. So there must be 10 students that walk to school. All right, cool. Now let's take a look at how many students bike. Uh-oh. Same problem. It's going to fall right in between two numbers. So now let's look at the two numbers it falls between so we can figure out what number it represents. The number of students that bike to school falls somewhere in between 4 and 8 students. So what number is in between 4 and 8? Oh, I know. It's 6. Of course. Awesome. So now we can answer our questions because now I fully understand my data. I have numbers, I know what everything means. Whew. Let's take a look at the questions. The first question up here, and I'm sorry I had to write small because I wanted to fit everything, says, how many more students ride the bus than ride in a car? Now if I have words like how many more or how many less and I'm comparing two things, I know that I'm going to be subtracting. So let me take a look at what I'm going to be subtracting. How many more students ride the bus, 24, than ride in a car, 16? So I'm just going to set up a subtraction problem. So 24 minus 16 equals, anybody? Huh? 8. Nice. 8 students. And now if I didn't have these bars labeled, that would have been a really tough question to answer, because I'd be like, that many more students? But labeling them, having the numbers to work with, makes it easier for us. Let's take a look at the second question. How many students walk and bike combined? Ooh, the word combined is letting me know that I'm going to have to add or use addition. So let's see, we have 10 students that walk and 6 students that bike. So I'm just going to add 10 plus 6 equals 16 students. Whew. The questions were actually the easier part of this whole thing, right? Once we had everything organized and we had everything labeled, that wasn't so bad, right? Awesome.